So we previously looked at transversals and lines, but now what happens if a transversal cuts through parallel lines? Well, some really cool relationships happen that help us out. So, real quick, there's a line, there's a line, there's a transversal. Parallel lines and a transversal. Well, look at this. That's 90 degrees. That's 90 degrees. That's 90 degrees. That's 90 degrees. These are all right angles. There are special relationships here. So let's just dive right in. And just like the last section with looking at transversal lines, we need to memorize these. We need to know these. So unlike previous algebra type problems and algebraic mathematics, this requires just basic memorization of these rules. So first is the corresponding angles postulate. So let's say that I have, again, these two parallel lines, and there's a transversal that cuts through them. First off, let's identify the corresponding angles. Right there and right there. Let's say we wanted to measure these. So if I pulled out a protractor, I want to measure these angles. So here, this angle down there, starting at 0, well, starting at 0, it goes to about, what's this, 130 degrees? Okay. Well, if we measure up here, look, it goes to that same 130 degree line. These are the same. So, whoops. Oh, there we go. I can make that smaller. So now we can definitely see. Look at that. It's the same measurement as the smaller angle. So I want to get rid of this now. I don't know how I do that. No, now I got 2. Okay, there we go. So corresponding angles when cut through parallel lines. So when a transversal cuts through parallel lines, so transversal through parallel lines makes corresponding angles congruent. And remember, congruent means the same measure. Congruent. With that little symbol. So these two angles are congruent. They're the same measure, just as these two corresponding angles are also the same, and these are the same, and these. So all of these corresponding angles are going to be congruent to each other. Alternate interior angles. Well, let's take a look at another set of parallel lines. And we'll have a transversal cut through this direction now, just to mix it up. Alternate interior angles. So there's one. And remember, these alternate interior angles make little zigzags. So the other one will be just like that. I'm actually going to take this. Let's see. Copy that. Paste this. Because if you notice this, they kind of look the same, right? If I were to measure these, well, when a transversal line cuts through parallel lines, it makes alternate interior angles congruent. So far, when we have a transversal and it cuts through parallel lines, it makes corresponding angles congruent, and it also makes alternate interior angles congruent. What about consecutive interior angles? Want to take a guess? Well, if I look consecutive interior angles, remember these are the ones that are same transversal but different lines. Do these look the same? They don't. So actually, let's measure these. So I'm going to pull out that protractor again. And down here, I'm going to measure this. And I'm going to find this to be, what do you want to say that is? 44? Maybe we can say, move it there, make it easier for us. It's about 45 degrees. Okay, 45 degrees. So let us, whoops. Can I rotate this? There we go. So that bottom angle was 45 degrees. So if I go down here, this actually looks like it's not perfectly flat. That might do it. So this one, whoops, starting over here, if I go and I count from 0 all the way to here, that's 35 degrees. So they're not the same. But is there some relationship between 135 degrees and 45 degrees? Well, if I add these two together, I get 180 degrees. So now our rule is when a parallel line cuts through, or sorry, when a transversal cuts through parallel line, it makes consecutive interior angles, well, not congruent, but if angles add up to 180 degrees, we call that supplementary. So this transversal that cuts through these parallel lines makes these consecutive interior angles supplementary. And really, you can get away with using alternate interior angles. Remember, this alternate interior angle and this alternate interior angle, they are congruent. So if this is 135, this is 135. Well, wait a minute. These two angles here in red and blue, they make a linear pair. They're on a straight line. They add up to 180. So this must be 45, meaning that these two consecutive interior angles have to be supplementary. So that's a nice way of looking at that. All right, then we have the alternate exterior angles theorem. So, oh, you know what? Let's mix it up. Let's go back this way. Alternate exterior angles, doesn't matter. So this one and this one, again, that same zigzag. What do they look like? And they're also congruent. So it's nice that I can just use that over and over again. So alternate exterior and alternate interior angles are going to be congruent when that transversal cuts through parallel lines. We can play around with this and see why that is, using all these different rules and looking at consecutive angles. And then we also have the perpendicular transversal theorem, which may be the last one. Yeah. So just to recap, alternate exterior, alternate interior, corresponding angles are all going to be congruent when a transversal cuts through two parallel lines. The only angle that is different is going to be consecutive interior angles. They are going to be supplementary. So hopefully that's kind of simple to remember. They're going to be congruent unless you're talking about consecutive interior, then they're going to be supplementary. Okay, so let's look at the perpendicular transversal, and this was just like the last one I did, or the first example I did. If I have a transversal that is perpendicular, it's going to be perpendicular to the other one, right? These are corresponding angles, so it must be, these two angles must be congruent. So you're actually going to have a whole bunch of right angles in here, which is nice. But the theorem is, if a transversal is perpendicular, no, I think that is an E. Yeah. Maybe that's an E. I don't know. I was never a good speller. All right, so if a transversal is perpendicular, see, now I'm doubting myself. It looks wrong, but I'm sure it's right. Oh, no, it's right there. Ah, boy. Okay. It's an E. It's just, it looks so wrong in this. I don't know why. All right, back to math. If a transversal is perpendicular to one parallel line, then it is perpendicular to the other. So see how this transversal, going down the middle, is perpendicular to the first parallel line? That means that it has to be perpendicular to the next parallel line. And that's the perpendicular transversal theorem. So let's look at these, and in the future I'm going to give you a problem where I just basically give you one big picture with a whole bunch of angles, and I give you one. So this one does the same thing. So angle 3 is 102. So we want to look at these rules. So angle 3 is 102. Angle 5 is alternate interior with that. So that's also going to be 102. Angle 6, these are consecutive interior. So they're going to add up to 180. So that means that this is going to be 78. If angle 3 is 102, angle 11 is corresponding. So that's also going to be 102. Angle 7 is also corresponding. Sorry. So that's another 102. 15, all the way down there. So what we can do is we can do a double corresponding. So 3 is corresponding to 7, and 7 is going to be corresponding to 15. So 15 is 102, and 14 is supplementary to 15, so that must be 78. So you can see that there's going to be a whole bunch of angles that are the same or supplementary. There's not going to be one random one like 53 that pops in there. All right, in this figure, angle 9 is 80 degrees, and angle 5 is 56. Sorry, 68. I don't know why I said 56. Angle 12. Angle 12 is going to be supplementary to angle 9. So that means that angle 12 is going to be 100 degrees, because angle 12 and angle 9 make 180 degree, make a straight line. Angle 1 is corresponding to angle 9. So that's going to be the same measure, and that's going to be 80. Angle 4. Angle 4 is here. Oh, it's supplementary to angle 1. So that's going to be another 100. And if I use angle 12, it's corresponding to angle 12. So that's the same. Angle 3. Angle 3 is consecutive interior with 12. So that is going to be 80. And also, if I think that angle 4 is 100, these are going to be supplementary. So you don't have to say, you don't have to use a certain angle relationship. Any of them are going to work. And that's a beautiful thing. So knowing that angle 3 is 80, I can, oh, actually, P and Q are not parallel. W and V are parallel. So if I have angle 7, I'm going to need to know angle 5. Angle 5, that's actually that's a vertical angle with angle 7. Remember vertical angles? We looked at them before. 5 and 7 are going to be congruent. So angle 7, that is going to be the same as angle 5, which is 68. And then 16 is, if I look here, that's either alternate interior. Sorry. No. That's just consecutive interior with 16. It has no relationship with 5. So be careful with that. So it's going to be supplementary with angle 7. So if angle 7 is 68, that means that 180 minus 68, which is 112, that's going to be the measure of angle 16. So that's some problems that we can do, and these are the problems that you're expected to do. So you can see that just knowing these theorems, knowing these rules, is going to help you. It's the only requirement to do these types of problems. There's no sort of manipulating, no algebraic trickery that goes on. So in order to solve these, you need to know these theorems, which hopefully aren't too bad, but definitely memorize them, definitely work on reviewing them. And as you go through these types of problems to start, always be looking at those rules and referring back to them.